This is section 10.6, part 1. We're going to start talking about how to solve radical equations, ones that involve square roots. So first, we need to arrange the terms in the equation so that one radical is isolated on one side of the equation, meaning that nothing but that radical is on one side of the equation. Then we square both sides of the equation to eliminate the square root. Then we solve the resulting equation. Now we need to note sometimes we might have more than one radical, and so after we do steps 1 and 2, we might still have radicals, in which case we'll have to do steps 1 and 2 again before we can solve. The solution to the original equation is among the solutions to the equation from step 3, but we need to check all possible solutions in the original equation to discover which ones are correct, because when we do this process, we can introduce extraneous solutions. And an extraneous solution is just an extra solution that is not really a solution of the equation. So if we look at this first example, the radical is already isolated. There's nothing on the left side of the equation but the square root. So we are going to square both sides of the equation. And when we do that, the squaring and the square root, they essentially cancel each other out. So we're left with 2x plus 3 equals 8 squared is 64. Now we just proceed to solve like normal. So subtract 3 from both sides. We get 2x equals 61, or x equals 61 over 2. Now we have to check. So we're going to plug 61 over 2 back into the original equation for x and see if it does indeed give us 8. So we have the square root of 2 times 61 over 2 plus 3, and we need to know if that gives us 8. So the 2 and the denominator of the 61 over 2 cancel each other out, and we're left with 61 plus 3. We still need to know if that equals 8. Sorry, the 61 plus 3 is under the radical. So we have the square root of 64. Does that equal 8? Well, the square root of 64 is 8, so yes, that checks. So x equals 61 over 2 is indeed a solution. Turning our attention to number 2, on this one, the radical is not isolated. So first, we need to subtract 7 from both sides of the equation. That leaves us with the square root of x minus 9 equals 3. And now we can square both sides of the equation. So once we square both sides of the equation, that leaves us with x minus 9 equals 9. And then we add 9 to both sides. So we get x equals 18. Now we have to check that. So we have 7 plus the square root of 18 minus 9. And we need to know if that equals 10. So 7 plus 18 minus 9 is 9, so we have a 9 under the square root. The square root of 9 is 3, so we have 7 plus 3 And 7 plus 3 is 10, so that checks. So x equals 18 is a solution. Okay, for the third problem, it's the same thing. I think you guys should pause the video for a minute and try to work it on your own before you come back and see if you got it right. Anyway, we have the square root of 3x minus 11, and then plus 9 on the outside equals 2. So first isolate the radical by subtracting 9 from both sides. That gives us the square root of 3x minus 11 equals a negative 7. Now we square both sides of the equation. And doing that gives us 3x minus 11 equals 49. So add 11 to both sides. We get 3x equals 60. And divide both sides by 3. We get x equals 2. Now let's check and make sure that, sorry, not 2, 20. Now let's check and make sure that 20 is indeed a solution. So if we check, we have the square root of 3 times 20 minus 11, and that's all under the square root, plus 9, and we need to know if that equals 2. So under the square root, 3 times 20 is 60, minus 11, and then plus 9 outside. So we have the square root of 49 plus 9. Square root of 49 is 7 plus 9. And we can already see that that's not equal, right? Because 7 plus 9 is 16. 16 does not equal 2. So this is false. So that means that x equals 20 is not a solution. So what does that mean? The only solution we came up with possible solution we came up with doesn't work. So that means there is no solution.